All right, first question we got is revert. We've got a review question number 4. This is review question number 4, number 17 in the algebra review. But if you go to the review study plan, it's like number 17. Okay. I have no idea what it is, but let's see what it is. Okay, good question. That's a good question because you got to know your algebra in this class. So let's go ahead and do this one. I'll bring up and that is a test question on the review part. I would put that on test. So let me minimize that. And that's going to be 1 over x plus 10 minus 1 over x over 1 over x. I got an email yesterday saying that we needed another trig teacher. I don't know if something happened to one of our trig teachers or not. Does anybody of y'all know that's got a trig class that don't have a teacher? I just wondered if y'all heard anything, because I know some of y'all know each other, bridge students. I didn't know if I volunteered for the 10 o'clock on Monday, Wednesday, and Friday. They wanted me to teach it. But I told them, I said, I ain't going to Pendleton campus. I said I could teach it like I'm teaching these classes right now. But I'll shut up. All right, so what is the common denominator of x and x plus 10? X times x plus 10, just like 3 times 7. There's nothing in common. So I'm going to multiply the top and the bottom by x times x plus 10 over 1 over x times x plus 10 over 1. I want y'all to distribute that. Go ahead and distribute it out. And I'm going to put a baby step in here for you. I'm going to do x times x plus 10, x times x plus 10, and x times x plus 10 over 1 over 1 over 1. I'm distributing it times 1 over x plus 10 minus 1 over x times, this will be 1 over x. I think I used 2 different shades of green. It bothers me, but it'll be all right. So now put them together. Well, first we got to do some canceling. So I look for my handy dandy red marker, and I'm going to cancel this x plus 10. And I'm going to cancel this x. And I'm going to cancel this x. And that's going to leave me with x times 1 over 1 is x. Minus, and I'm going to put parentheses here, x plus 10 over x plus 10. And x minus x, well, that negative turns that into a negative and that into a negative. It's hard to write. I'm going to have to move this up because I'm at the edge of my table. Okay, see the table goes right here. Okay, so that's going to be x minus 10 over x plus 10. And we see the x's cancel. And you're left with negative 10 over x plus 10. Now, I would assume that that's the answer. But let's go back and check it. negative 10 divided by, oh shoot, negative 10 divided by, I don't forgot it, x plus 10, x plus 10. And you should feel good about yourself. And we do. Good question. That's a good test question. I would be glad to put that on the review test. Okay. Next question. I'm going to delete that question so I don't do it over. Next question is review 6, number 25. Review 6, number 11. So if you're working on the review section and you go to study plan, this is like number 11. It's also question 25 on your homework. Write with radicals. Now remember, when you start with radicals, when you're doing things with radicals, remember the basic rule. The basic rule is the square root of x to the first power is equal to x to the 1/2. So that means exponent over what? Over the index. All right, so we know that the exponent goes over the index. So in this case, we've got 4y plus x raised to the 4/5 power, and we know that we've got exponent over index. So we got the 5th power of 4y plus x to the 4th power. That should be your answer. Now, a lot of people don't know how to type that in. Well, you got to use the key down here, and that'll be the 5th power of parentheses 4y plus x, 4y plus x, close parentheses, raise, shift up to the 4th power. And you should feel good about yourself. Yay! That's a test question. Okay, so out of the review, there's 2 good test questions that we could put on the test. Questions so far? Okay, we got some chapter 9 questions. Let's see which one's first. That's 11. That's 31. That's 11. So we got 2 9/11s. So we'll do one, and then I'll do the other one for backup. Let's see what this is. Find the complementary and supplementary angles to 2 pi over 7. Okay, well, I tell students you can do this 2 ways. All right, what do you mean, Hubert? Well, there's 2 ways you can do this. First of all, it says complementary, so we know that means what? 90 degrees. Well, on a unit circle, which we haven't covered yet, and that's why I don't like this question. On a unit circle, we've got, I'll just draw a circle right here. And you better learn it. We'll learn it here in a little bit. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. Everybody with me? Okay, so we're going to learn this a little bit later, so it's not like you got to learn it right now, because I'm going to show you another way to do it, but this is how you do it. Okay, 2 pi, we know that the area, that the 2 pi over 7, we know that it's in, where's my yellow highlighter? We know that it's in this section. Somebody tell me how we know that. You can type it in or you can say it out loud. How do we know that the angle is in 2 pi in that first quadrant?
It's positive. It's less than pi over 2.
Okay, but what does the word, what word am I looking at?
Complementary.
Complementary, write that down. Complementary tells us it's 90 degrees, less than 90 degrees, or equal to 90 degrees. So that's why the word complementary tells us it's in this first complementary. Complementary tells us it's in the first quadrant because it's got to be less than or equal to what? 90 degrees. So let's just draw 2 pi over 7. We'll just draw it in here somewhere. We have no idea where it is, but we know that that angle right here is 2 pi over 7. So instead of 90 degrees, it's equal to pi over 2. So one angle plus the other angle is equal to pi over 2. We know one angle is 2 pi over 7. And we'll call this angle x. So what are we going to do? We got to subtract. So I'm going to get rid of 2 pi over 7 minus 2 pi over 7. And that's going to give us x by itself. And this is a test question. But y'all said I hadn't gone over it. No, I haven't. So we're okay. X is equal to, what do we got to have to add fractions? That's not rhetorical. I'm asking y'all to interact with me.
Common denominator.
Common denominator. So I got to put a 14 here and a 14 here. 2 will go into 14 7 times. 7 times pi is 7 pi. 7 will go into 14. 2 times 2 is 4 pi. What's our answer? 3 pi over 14. Now that's one way to do it. Now I'm going to do it another way. If you walk up to an engineer or an architect and you say, okay, we're going to set a stake at 2 pi over 7 radians. They're going to look at you like you're foreign, live from a foreign country. Nobody talks in terms of radians. So we're going to change it to what? Degrees. Now, the way that you change a radian to degree is you cancel out the pi. So that means that 2 pi over 7, I've got to have pi on the bottom, and that means I've got 180 on top. So to change a radian into, it's supposed to be multiplication, into, let's change a radian, and I believe that's where we left off. We didn't go over radians, and we'll go over it today. To change a radian from pi to degrees, multiply by 180 over pi. Or just remember, you got to get the pi's to cancel. So take my red pen and the pi's cancel. And 2 times 180 is 360. And 360 divided by 7. Somebody take 360 for me with the calculator. And divide that by 7. What do you get? Okay, I'll do it.
51.42.
51 point what?
42.
Now that's a decimal. So 428, that's a decimal. So we need to change that to degrees, minutes, and seconds. So how do we do that? Well, 51 degrees And somebody take 0.428 and multiply it by what? Y'all just not going 60? Somebody do that for me.
60.
And tell me what you get. What's 4.428 by 60?
25.68.
25. And then the 0.68, what do we multiply that by?
60.
The 60. Multiply that, tell me what you get. 51 degrees, 25 minutes, and what?
40.8.
I'm sorry, for what?
40.8.
40.8 would be 41 seconds. And that is your angle. So now we're going to do it the other way. So we've got an angle. I'm going to draw it for you. We've got an angle. This is equal to 90 degrees. And we've got an angle of 51 degrees, 25 minutes, and 41 seconds. Now you can find this angle by just doing what? Subtracting. So 90 is 89 degrees, 59 minutes, and 60 seconds. Minus 51 degrees, 25 minutes, and 41 seconds. And that's going to be 10 minus 1 is 9. 5 would be 19. 59 minus, what is that, 4 and 3. And 9 minus 1 is 8. And 38, 34, 19. Now, if you wanted to change that back into radians, you would have to multiply by 3600 and 60 and then change it. But you can see it's going to be about the same. If you was to change, we'll change this answer right here, change it back into the 180 over pi, and that's going to be 3 times 180 over 14. Somebody multiply, I'll do it. 3, I'm just doing it long ways. I'm not going to cancel. 3 times 180 divided by 14, 3857. Is that what we got? Yep. 38 degrees. And that comes out to be, it's going to be, they're going to, if you transverse it over, it's going to be the same. So you get the same answer. But they want you to do it like this. Okay, so what I'm going to do is type in the answer as they want it. So what do we get? We got 3 pi over 14. So 3 pi divided by 14. And we feel good about ourselves. Okay, but somebody else sent another one. Okay, supplementary. So let's do supplementary. Supplementary is going to be here, like that. We know this is 0, this is pi over 2, and this is pi. So we know that this angle is 2 pi, what is it, 2 pi over 7? So you would just say pi minus 2 pi over 7. So pi over 1 minus 2 pi over 7. And of course, you got to have a common denominator. So 7, make that 7 pi minus 2 pi over 7 is equal to 5 pi. over 7. So this angle right here is 5 pi over 7. So this one's going to be 5 pi divided by 7. Man, that's a good test question. It's not a big deal. I mean, you can do it either way, but it is a little bit easier if you do it by the pi's. Now, somebody sent that same question, so let's do it over, and I'm going to let y'all do this one, and then we'll do it together. So this one was sent by Mr. Johnson and Johnson, and that is 9.111. Okay. Now, actually, you shouldn't have done it because I haven't covered it yet, but that's okay. That's good. That's a good thing that you're doing it. But I hadn't covered it yet because I was getting into this, and I told you I wasn't ready to do radians. What was that, Thursday? I wasn't ready to do it, so that's why I didn't do it. All right, so anyway, here we go. Supplementary. Let me pull in my handy dandy, move that over. So we know this is 0 and this is pi over 2. And this is pi. And we got an angle sitting here, and it's 3 pi over 8. So A is going to be pi divided by 2 minus 3 pi over 8, which is 4 pi minus 3 pi over 8, because 8 is the common denominator. And that leaves you with pi over 8. Okay, supplementary would be pi. So B is pi over 1 minus 3 pi over 8, which would be 8 pi over 8 minus 3 pi over 8, which is 5 pi over 8. Okay. So far, those are 3 good test questions. And let's go to the next homework question. This is 9.131/7. Okay, this is a test question. So let's do it. 5618 minus 3650. Now, what's the problem with this? What's the problem with this problem? Somebody either speak it or say it. What's the problem? If there's a problem, we can't do it. Why? Come on, I know somebody knows.
You need to convert 1 degree into 60 minutes.
In other words, we can't take 50 away from what? You can't have a negative
18.
minute. You can't take 50 away from 18. Just like back in preschool. 179 minus 10, or minus, I can't think of one right now, minus 82. Okay, I can't take 8 away from 7. Hold on. I keep forgetting to bring this up. Sorry. I can't take 8 away from 7. So back in those days, you were told to what? Borrow 1, and then make that a 17. Okay? Okay, I know that's not a good example, but anyway, y'all remember borrowing back in the day, back in grammar school? Well, you're gonna do that here, except one degree. I mean, I'm gonna borrow 1 degree from here, and that's got to come down as minutes. So I'm gonna borrow 1 degree from 56, and that's gonna make 55. So 55 degrees. And that 1 degree comes down as minutes. So 60 minutes plus 18 minutes is what? 60 minutes plus 18 minutes is 78 minutes. Minus 36 degrees, 50 minutes. Now we can subtract. 78 minus 50 is 28. And 55, let's see, 5, that'd be 15. That'd be a 9. And then that'd be a 4. I got 19 degrees, 28 minutes. Now, of course, you can check it by adding these two together. So we're going to check it because you'll see, I'm going to check it in green. So I'm going to add 36 degrees, 50 minutes. For the check. So that's going to be 78, and then 9, that'll be a 5, and then 1, 3, 4, 5, 55 degrees, 78 minutes. But there is no such thing as 78 minutes. There's only 60 minutes in a degree, so that's going to bump that 78. There's only 60 in a degree, so that's going to bump this up to 56. And then 78 minus 60 is 18. And that does check with what we were working with. Okay, and that is a test question. So make sure you know. And I think that's what we were doing Thursday when we left class. I think we just went over this. And I was thinking we were going over, let's see if this is right. What did I get? I got 55, 70, 36, or 19, 28. 19 and 28. Oops. Oh, come on. 28. There we go. That should be it. Okay, that's all the, oh, we got another one right there. I didn't see that one. Let me see what that one says. 9.111, that's the same one we did a while ago. So hopefully that helps you. Yeah, 5 pi over 12, I think we did one. That was 5 pi over 12. Didn't we? I can't remember. Well, that'd be 6 pi over 2, wouldn't it? Let's see. Pi over 2, yeah. Yeah, we did one like that one, I think. All right, so let's move on. Let me delete that one. I have no more questions. So let's move on. Let's go to the most important page. And where is it? Where? Oh, there it is. Let's go to the most important page. I don't know why I'm in 120. Need to be 111. Oh, I know why I was in 120. It's helping a student. Okay, the most important page is line 1. We still got to finish line 1 because I feel like I'm not finished. I think we were in line 1. All right, so I'm going to go down here and pull up the 9.1 and e-text, and I'm going to get to the radians. Because that's what we went over last. Or that's what I was fixing to go into Thursday. And it should come up eventually. Hopefully. I think we got to this. Now, I do this a little bit different from the book, and you don't do this very often. You might have one test question like this, but when they give you like 908 degrees, I'm just going to show you how I do this. Okay, 908 degrees. So 908 degrees means that you're going to be going around the world more than 360 degrees. All right. We know that a circle has 360 degrees. When they give you a problem with 908 degrees, when they give you a problem like that, 908 degrees equals what reference angle? Okay, that's what they're asking you. Well, nobody, you don't walk up to an architect or a construction manager and say, we need to turn 908 degrees. That's ridiculous. And honestly, it's ridiculous to be in here. I mean, there is no such thing as 908 degrees. It doesn't exist. So why do they do it? Hell, I don't know. All right. But we're going to turn it into a normal degree that you would walk up to somebody and say, we need to turn blank degrees. All right. So first thing I tell students to do is I tell you to divide 908 by 360. 908 divided by 360. So I take my handy dandy calculator and I say 900, turn it on first, 908 divided by 360. That's 2.52 equals 2.52. So I know that two circles will go into 908. So what is two circles? Two circles is 720. So 2 times 360 is equal to 720. And then I subtract 720 from 908. Now this is the way I tell students to do it. Sorry. You don't have to do it this way, but this is the way I tell students to do it. So I take 908 minus 720. And the reference angle is 188 degrees. So I'm going to take my orange pen and I'm going to draw 188 degrees. Here's 180. So 188 would be right about there. So you would go up to somebody at a construction site and say, I need to turn 188 degrees. You would never walk up to somebody and go, well, let's do this in green. 1, 2, and then there, 908 degrees. Nobody would ever walk up to you and ask you to turn 908 degrees. There are no applications to turn 908 degrees. I think this is one of those things that they have taught in trigonometry for hundreds and thousands of years, and you just have to do it because there is no application for 908 degrees. So is equal to 188 degrees. It's called a reference angle. Now that's how you do it. Now what about the next one? It says, okay, let's see if we got that right. 188 degrees, look at there. All right, now 75 degrees, negative. Negative 75 degrees is actually in the real world turned the correct way, but we're not going there. Negative 75 degrees is right here. Now that's not hard because they want you to find this angle. Let's see. They want you to find this angle. So in this case, it's real easy. You just take 360 minus 75 degrees. And that's going to be 10, 5, that'll be a 15, and an 8, and a 2. So that orange angle is 285 degrees. Now this one has application. This one has application. But in the real world, you would not turn 75 degrees, you would turn 285. I'm sorry. In the real world, this one right here is the one you would turn because it's smaller, and you're turning to the right. You always want to turn to the right with a theodolite or a transit. Keep everything consistent. You have to get into the mechanics of the actual instrument to understand what that is. But one thing that's always good in statistics and engineering, surveying, because you always want to be accurate, is what? Always do the same thing, what? Over. Always be consistent. Okay? And that's why when you turn an angle in surveying or engineering, you always want to turn it the same way. Okay? So that's why the negative 75 is, if that's basically saying I turn 75 degrees. If you walk up to me as a surveyor and say, turn 52 degrees, I'm going to turn it to the right every single time. Okay? Let's do the third one for good measure. I don't know what the third one is, but let's do it. The third one says negative 800 degrees. Negative 800 degrees. Nobody ever would walk up to you and ask you that, but negative 800 degrees, and I'm not even going to write it. I'm just going to say negative 800 is equal to blank degrees. Negative 800 degrees. First thing I'm going to do, we know it's turning this way, so that's the negative. So I'm not worried about the negative. Negative just tells us direction. So with that being said, somebody divide 800 by 360. So I'm going to do that with my calculator because y'all don't want to talk to me. 800 divided by 360. So I know I have 2 revolutions. I have 2 revolutions, so that's 720. So I'm going to subtract 720 from 800. And I know I got a degree in everything. I know that's going to be like 80 degrees. Okay? So that means negative 80 degrees is my angle. So negative 80 degrees would be somewhere in there. And that's it. And if you wanted the reference angle, that would be 260 degrees. You could say 260 degrees. Let's see, what's 280 degrees? 200 degrees here. Now what they're wanting you to do is take the black marker, and that's going to be 1, 2, there's 800 degrees. So let's check our answer and see if it's either negative 8. I believe the answer is negative 80, but they may want the reference angle to negative 80, which is 280. One of the two. 280. They want the reference angle. Okay. Those are 3 good test questions right there. I wouldn't ask you any more, any less. Hopefully some of you are adjusting to trigonometry, because that's what this chapter is for, suggesting.
I have a
Radian.
question.
Go ahead. What's your question?
When we're doing the test and we have questions like this, do you want us to give you the reference angle or the other angle?
It should be the reference angle. That's
Okay.
usually what they're asking. Now,
Okay.
if you mistakenly put the other angle, I probably will accept it. You just have to see me after class and I'll accept it. But I don't want you worrying about it. Okay? Go with the reference angle. In other words, the 280 degrees. Hold on. Trying to get it. The green, go with that. All right. In other words, 800 degrees, negative 800 degrees gives you negative 80 degrees. You see that? All right. The reference angle to negative 80 degrees is 280 degrees. So the answer would be 280 degrees. Okay.
Okay. Thank you.
Try to give me the reference angle. If you accidentally give me negative 80 degrees, I probably will fuss at you, but I'll probably give you the answer. But that's why you have 3 chances on the test. You know, if you get that wrong, you know why you got it wrong. You typed in the negative 80 instead of the 280. But that's the green is the reference angle. Because of this negative, that negative is the actual angle of 800 degrees because it's negative. This is the reference angle is always the opposite sign. So if you start with a negative, your reference angle is going to be positive. If you start with a positive, your reference angle is going to be negative. It's always the opposite sign. Radian, write this down. You don't have to write down every word, but an angle with a vertex at the center of a circle and intercepts an arc on the circle equal to 1 radian. So this is equal to this distance. These two distances, all 3 of these distances are the same. I'm going to blow that up. Well, let me just rewrite it on the thing over here. When you have a circle and you have a radius here and you have a radius here, those 2 are equal. Okay?
We can't see your board.
I know. Those 2 right there are equal because the radius is the same no matter what. When this and the distance around this are equal, it's a special circle, okay? When that distance and this distance and this distance are all equal, that's called a radian. We'll put an R here. And that right there is called a radian. And all 3 of those R's are the same number. Now the first 2 are not a problem. These 2 are easy to be, but you have to put these 2 in the precise place to get this R to equal these 2 R's. And this angle is a certain angle that these 2 R's will equal that R. That's a radian. So if you want to use that as a definition, where the 2 radians is equal to the outside radius, that's a radian. But there's only one place on the circle that there's a radian, and that's where this is equal to these 2. An angle with the vertex, center, and arc on a length of radius is equal to 1 radian. Okay, so there it is right there. That R is equal to that R is equal to that R. Now this is what you need to write down right here. I'm going to write it down on my sheet. 1 degree is equal to pi over 180. And 1 radian is equal to 180 over pi. Now, that's the difficult way to learn it. The easy way to learn it is what are you given? Let's say you're given 36 degrees. Let's go with 30 degrees. Let's say you're given 30 degrees. And they say 30 degrees is equal to blank radians. Well, somebody tell me what unit do we have in the problem? This is the problem right here. What unit do we know? Degrees. So that means I'm going to put 30 degrees over 1, and I've got to have degrees to cancel in the bottom down here. Well, there's only one. That'd be pi over 180. Because that one has degrees in the bottom. And now you just cancel the degrees. And you get 30 pi over 180, and what do? You reduce. That's the easiest way to do this. And I know trig teachers that go through the whole unit of 9.2 or 9.1, and they don't show students that relationship of canceling. They don't do it. So let's cancel with a 0 and a 0. 3 will go at 18 6 times. So it looks like to me, the answer is pi over 6. That's the easiest way to convert radians to degrees and degrees to radians. So let's do another one. So change that problem we did a while ago. 5 pi over 12 equal to blank degrees. Somebody tell me, what unit do we know? Not what do we want, what do we know?
Radians.
Radians. We got radians right here. So 5 pi over 12. Somebody tell me what I got to have in my denominator over here.
Pi.
So which one of those two has pi in the denominator? 180 over pi. The pi's cancel. And you're left with 5 times 180 over 12. 6 will go into here 2 times. Two will go into 30, 15. I don't know if this is right or not, but 5 times 15 is what, 75? If I've done my math right, should be 75 degrees. Somebody check my math down here, make sure I didn't make a mistake. Let's see, 6 will go into 12 twice. 30, I think that's right, excuse me. So that's how you, and these are 2 test questions right here. 30 degrees equals blank radians. So make sure when you're doing homework problems, you do a couple of these. And radians equal blank degrees. And that's how you do it. You just got to remember 180 over pi and pi over 180. You don't even have to remember the conversion. All you have to remember, if I give you 70 degrees, put it over 1. And what goes in the bottom? Degrees. So that's got to be 180. You got to have something cancel. And you don't know what This one is, so you can't cancel that one. The only thing you know is the degree, so that dictates degree in the bottom. Well, what if you have 2 pi over 2 pi over 3? Well, 2 pi over 3. What unit do you have? Pi. Which one has pi in the bottom? 180 over pi. Simple as that. You don't have to try to remember anything. All you got to know is 180 over pi, pi over 180, and then use as needed. You'd be surprised on how many people go through Trig and the teacher does not show them that relationship. They do this crap right here, and then the student right here is confused by the way it's written. All you got to remember is try to cancel out what you're given. Here, I was given degrees. I got to cancel degrees, so that means 180 goes on the bottom. Here, I was given pi. That means pi has to go on the bottom. You're done. So this is going to be 7 pi over 18. And this is 3 will go into 60, 120 degrees. And there's one more extra question right there that I could give you on a test. Degrees to radians, radians to degrees. Next, there you go. And you can learn how to do it in calculator. They show you how to do it. I'm not really concerned because most people, you know, when you show them that relationship, they just know how to change it. Just like 9 pi over 4. I'm going to do 45 and 9 pi over 4. Not even going to look at it. 45 and 9 pi over 4. 45 degrees equals how many radians? And what I say, 9 pi over 4? 9 pi over 4 equals how many degrees? Okay, that's 45 over 1. 45 degrees over 1 means I'm going to multiply by pi over 180 because those degrees cancel. Here, I'm going to take 9 pi over 4 and I'm going to multiply by 180 over pi. And how did I know to do it that quick? Well, this degree dictates that degree has to be down here so they can what? So they can cancel. This pi dictates that pi has to be on the bottom. So these two can cancel. And now you just do your math. So here, I'm going to get 45 pi over 180. And I know 9 will go into both of them. 5 pi over 20. I have no idea. Let's see, 20 times 9. And that's going to be pi over 4. And then this one is 4 will go into 180. 4 will go in there like 16. That'll be what, 4? 45. I'm thinking. I think that's 45. That's a big number though. Okay, 9 pi. Okay, so 4 will go into, that'll be 4 times and 5. And 9 times 45, 9 times 5 is 45, bring you 5. 9 times 4 is 36, 415 degrees, which that's the reference angle, minus 360. Somebody minus 360 for me. What would that be, 55 degrees? Somebody minus 360.
Yeah, 55 times.
What is 324? Did I do something wrong? Check, make sure. Let's look at the problem and see what they got.
Wouldn't it be 405?
Wouldn't it be what?
405, not 415.
Okay, thank you. Thank you very much.
No problem.
Okay, now subtract 360 from 405. 9 times 5 is 45. 9 times 4 is 36. Yeah, 4405. Now, what's 305? What's 405 minus 360? 45?
45.
So 45 degrees is the angle. I don't know what they got, but which one did we do? We did that one. They got pi over 4. We got pi over 4. And here, 405. Now, 405 is academia. That's not the real world. Like I say, you don't walk out to a construction site and say, we need to put another so-and-so at 405 degrees. They'll look at you like you're crazy. And you sure as heck ain't going to go out there and say, well, we really need to go pi 4 radians over. They'll look at you like you're a nut. Okay?
So on a test or a quiz or anything like that, you always want to find the reference angle, or should we go?
Well, it depends on the directions. Here, the directions say convert each measure to degree measure. Doesn't say reference angle.
Okay.
So I just did that to give you another lesson in a reference angle. That's the only reason I subtracted the 360. Okay. The 405 is the answer.
All right.
Now, if the directions say convert each radian measure to degree measure in simplest form or in reference angle. If it had reference angle or simplest form, then you would change the 405 to a 45 degrees or whatever. Okay? All right. So let's see what that takes us to. The unit circle. Okay, now I'm going to tell you, there's 2 ways to do this. Let me check, see what time it is, so y'all don't go into convulsions. Okay? All right, we got about 20 minutes, something like that. All right, or no, I'm sorry, 10 minutes. Yeah, well, technically we got more than that, but anyway, 18 minutes would be 36, so we got 17 minutes. All right, so there's 2 ways to do this. One is to go to Google and look up unit circle, pick you out one that you like. Oops, sorry, unit circle. And copy and paste it onto a word processor, and that's it. Okay, does everybody understand that? Unit circle, pick out the one that you like, and go with that. Or you could learn how to make your own. Well, Hubert, I can't. Yeah, you can. You can do it because you know how to do it now. What do you mean you know how to do it? You ain't showed us how to do it yet. You already know how to do it. Let me show you. It's a trick I learned in the war. All right, so draw a circle. It would be better to use a coffee can or something because some people can't draw circles like me. All right, so here we go. There's a circle and divide it into quadrants. You know this is 0. You know this is 90. You know this is 180. And you know this is 270. Now, if you don't know that, then we have problems. All right? And that's 360. Well, that's all I know how to do. Well, there's 3 special angles. I haven't showed you this yet. But there's 3 special angles in Trig. And I need you to write them down. There's the 30-degree angle. Let me put it on another piece of paper. There's a 30-degree angle. There is a 45-degree angle. And there is a 60-degree angle, which is a 30-degree angle turned on its side. So this is the 30-degree angle. This is the 45-degree angle. And this is the 60-degree angle. Now I'm going to go ahead and show you these special angles because we're going into that next. But I'm going to go ahead and put that on the unit circle, this is equal to 1, and this is going to be equal to square root of 3 and 2. And this is equal to 1, 2, square root of 3. And this is equal to 1, 1, square root of 2. Now, you don't need to know that for the unit circle, but might as well write these down because this is a 30-degree angle, this is a 45-degree angle, and this is a 60-degree angle. And those angles is what's going to make up your unit circle. And you're also going to see this in the next section, which is 9.2. But not right, you're going to see those numbers. But anyway, let me go ahead and show you how you're going to fill out your unit circle. Well, now that you got the three angles, 30, 45, and 60, now you can fill out your unit circle. How do you do that? Well, draw, if you want to, draw 3 lines this way that extend. Okay, now let's fill this side out. Well, what is 30 degrees plus 180? This is 30. See this 30 degrees coming right there? That's 30 degrees right there. What's 30 degrees plus 180?
210.
It's a miracle. Well, what's 45 degrees plus 180? What's 270 minus 30? Because if this is 60, what's 270 minus 30? Or you could say, what is 180 plus 60? I guarantee you there's somebody in here that went through pre-calculus or went through Trig and nobody showed them how to learn the unit circle. They told them to memorize it. You don't have to memorize it. You just have to learn it. Well, what do you do on these quadrant? Well, draw your, that's a 45, and that's a 30. What's 30? What's 180 minus 30? Thank you. Appreciate the interaction. Okay, what's 90 plus 45? Or what's 180 minus 45? And what's 90 plus 30?
120.
It's a miracle. Extend. What's 360 minus 30? What's 270 plus 30? What's 270 plus, oops, sorry. What's 270 plus 45? It's a miracle. I did not memorize one single thing. Now let's do the other part. 30 degrees over 1 multiplied by 180. I'm sorry, I just screwed up. Pi over 180. 30, 60 to be pi over 6. So 30 degrees is equal to pi over 6. Now you use pi over 180 and you convert all these to radians. 45 multiplied by pi over 180 multiplied by pi over 180 Well, that's going to be 6. 6 will go in there 3. That's pi over 3. We know this is pi over 2. We know this is pi. We know this is 3 pi over 2. And this is 2 pi. And now you can fill out your unit circle. Let's do 120. 120 over 1 pi over 180. Well, that will cancel. 12, let's say 6 will go in there, 2. And that's 3, so 2 pi over 3. So 120 is equal to 2 pi over 3. 150. 150 over 1 multiplied by pi over 180. The zeros cancel. 3 will go in there 5 times. And 6. So 150 is equal to 5 pi over 6. Now, I'm filling this out right now, and I have not memorized it. To this day, I have not memorized the unit circle. When I draw the unit circle, I just draw it by what I know. I don't memorize it. And how many of you, let's see the hands. Let me turn back to the enrollment where I can see. How many of you were told in pre-cal or calculus, you have to memorize the unit circle. If you memorize it, you pass. If you don't memorize it, you fail. Yeah. And I guarantee you somebody out there is going, oh man, I can't believe that. You just do the math and you can figure out the unit circle. Yes. Now it does help to know it, after you do it, it's kind of nice to be able to ascertain it quickly. But you will be able to do that later. But I guarantee you, there's people out there that nobody showed them the relationships that I'm showing you right now, because I was never shown the relationships. All you got to know is those 3 angles, 30, 45, and 60, and you can fill out the whole thing. Okay? And let's do 210 for good measure. Let's see, 210 divided by 1 multiplied by pi over 180. That 0 cancels. 3 will go into 21. That's 7 pi over 6. So 210 is 7 pi over 6. 240, let's do 225. 225 over 1 multiplied by pi over 180. Now you're going to have to divide by 5s because 1 ends in 0 and 1 ends in, so that's going to be 5 will go into 225, what, 15? No, 45. I'm looking, let's see, 5, yeah, 45, and 45 pi over 180. 5 will go in there, let's see, 3 times. 36. 9 will go in there. So I'm going to say 5 pi over 4 is 225. Okay? You understand it? What is we got you blessed up? What are y'all talking about? Okay, does that mean that everybody's convulsing? Oh my gosh, it's time to go. I'm sorry. No, it's not. 12:35. Okay, I'm good. Okay, well, y'all take a look and see who's here. Okay, we got you. Homie has to go to work. Okay, that's a whole lot better than we got you fam. I don't understand that. Y'all have to help me out there. All right, so let me get the roll and make sure. And I think, I don't know, y'all look. Let me see right quick. I think that will finish No, area and length. Okay, they make this first section so long. Arc length. S is equal to R times theta. And you can look at the example there. They do one with radians and do one with degrees. So that's it. After that, that's it. That should be it. We'll cover that. Let's see. Area of a sector. No, we got that to cover. I thought we'd be in, dadgummit, I thought we'd be finished. They make 9.1 so long. Okay, there really should be 2 sections, but that's just my opinion. All right, so we'll finish up. Let me call the roll, shut the camera off, and shut the presentation off. Stop recording.